Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 academic students who are studying the measurement and geometry unit. It's video number 2 of the geometry portion of that unit. So in the last video we had started looking at different sided shapes and their angles. So we reviewed the fact that the angles in a triangle add to 180 degrees, and that angles in a quadrilateral, a four-sided figure, add to 360 degrees. And we also talked briefly about the fact that a special type of quadrilateral is called a parallelogram. And in a parallelogram, opposite sides are equal to each other, and they still add to 360. So then we had this guy who said, well, what about five-sided shapes? What about six-sided shapes? Oh, what about 18-sided shapes? Is there a pattern? So these are good questions to ask, and in fact, he's right. There is a pattern. A three-sided shape has 180 degrees. A four-sided shape has 360 degrees as the sum of the interior angles. Five-sided shape, 540 degrees. Six-sided, 720. Seven-sided, 900. Now, a couple things. First of all, we know that this is a triangle and this is a quadrilateral. I don't need you to memorize the names of shapes like pentagon and hexagon and septagon. All you have to do is call them, for example, a six-sided polygon. Don't worry about knowing the special names because, I mean, what if I got here? I certainly don't know the name of an 18-sided polygon. I would just call it an 18-sided polygon. So don't spend time memorizing all those fancy names if you don't already know them. It's fine if you don't. But let's look again at this pattern. Well, we know from having done most of the grade 9 course that if I give you a table of values and say look for a pattern, I expect you've already done this, perhaps mentally. That the first differences here are add 1, and the first differences here are add 180, and you've already realized that this is a linear relationship. That there is indeed a pattern, and luckily for us, it's a linear pattern. And so if I said the sum of the interior angles is equal to 180 times the number of sides plus some sort of starting value that we don't know yet. So let's find the actual equation that will help us calculate the number of sides of, for example, an 18-sided polygon. Because certainly you could just memorize this table, and then you could sit down on every test and keep going. So this would be 8, and this would be 1080, and this would be 9, and this would be whatever. But that's kind of going to take you a long time, and it's not very mathematical, really. So instead, we know that delta S and was equal to 180, and delta N was equal to 1, and therefore the slope of this relationship is 180 over 1, and we just have to find B, or the starting value. So let's do that the way we always do it, which is we're going to substitute in a point that we know. So I'm substituting in 3 and 180. So N is 3 and 180 is S, and look what happens. 180, oops, equals 540 plus B. So negative 360 equals B. So here's the formula. S equals 180, N minus 360. That's a formula that will tell you the sum of the angles in any sided polygon. Now, it's often also written like this, and you're welcome to memorize it in any form. Basically, this says take the number of sides, subtract 2, and multiply by 180, and you'll know how many degrees the interior angles add to. So for example, let's go up here and let's figure out how many degrees would the sum of the interior angles of an 18-sided polygon add to. So if I have an 18, so imagine an 18-sided polygon. I mean, I'm not going to be able to draw it, but like all these little sides here like this. Oof, almost a circle, kind of. Okay, so the sum of the interior angles would be 180 times 18 minus 360. So that would be 180 times 18. So 3,240 minus 360. So the sum of the interior angles is 2,880 degrees. So you are supposed to know this rule, or this rule, whichever one you like better. But I personally like the idea of you knowing how to develop that rule more than just memorizing the rule. But certainly you should know this rule. One way or another, please know. And in fact, here's a question based on that. It says, what is the sum of the interior angles in a 14-sided polygon? So again, we know, this time I'm going to use the other version of the formula. I'm going to use this one. So n is 14, so the sum of the angles is 180 times 14 minus 2. So it's 180 times 12, and in your calculator, 180 times 12 equals 2,160. And again, what that means is that if I were to measure this angle, plus this angle, plus this angle, plus this angle, and so on, that all of those angles together would add up to 2,160 degrees. That's what that means. Now, a regular polygon is defined as a polygon where each side is the same length and each angle is the same measure. So it's regular and it's, the nicest one we have. Every side is the same length and every angle is the same measure. So if a 14-sided polygon is a regular polygon, what is the measure of each interior angle? So let's go back to this diagram here, because this diagram actually is a regular polygon. And again, that means that each of these sides is exactly the same length, and therefore each of these angles is exactly the same measurement. And the question is, what is the measure of each of these angles? Well, we already know that the sum of the angles is 2,160, and we know that there would be 14 of these angles because it's a 14-sided shape. So we could just say, take 2160, the total of the angles, divide that by the fact that there are 14 equal angles, and we could tell you, that each angle would measure about 154 degrees. Not quite, but pretty close. It's a weird decimal, but that happens. So again, each of these angles here is 154 degrees. Okay? So now we know regular polygons and we know how to find the sum of the angles in any sided polygon. So what's next? An excellent math question. So this question is actually directly from the EQAO in 2009, and I think it's a great question. So in fact, what I want you to do is I want you to press pause on this video, and I want you to try to get the answer to this question without me. And when the video starts up again, I'll take up the answer. So I'll see you on the flip side. Okay. So welcome back. Hopefully you pressed pause like I asked you to. It says, Nicole notices this star design on the pavement outside a movie theater, the Hollywood Walk of Fame. Determine the sum of the angle measures in the corners of the star. So I need to find out what is the sum of A plus B plus C plus D plus E. And again, there's absolutely no point in owning a protractor and trying to measure. That will not get you marks. That is not the point of high school geometry. Now I know from the past that some students look at this question and they say, Miss, there's no numbers given to me. How can I possibly tell you what A plus B plus C plus D plus E is if I don't even have a single number given? Well, you're right, but that doesn't mean this is an impossible question. If you look in the center of this diagram, you should see a lovely, regular, five-sided polygon. So it's 5 sides, and it's regular because we're told that each side is the same length. And if each side is the same length, then I know that each angle measures the same angle. So each of these 5 angles in that pentagon, or 5-sided figure, is the same measurement. So I'm going to figure out, in a 5-sided shape, what is the sum of the angles? And then I can divide that by 5, and it will tell me what each of these angles measures. So the sum of the angles in a 5-sided shape. So here's one of the formulas you can memorize. So I'm going to do 180 times 3, and that gives me 540 degrees. Now, because it's a regular polygon, I can just divide that into 5 equal pieces, and that'll tell me that each angle is 108 degrees. Oops. So this is 108 degrees, this is 108 degrees, 108, 108, and of course this is 108. Now how do I use that information? Well, now we have to use some of the other properties that we know about angles. For example, there's a straight line right here. And we know that the angles in a straight line add to 180 degrees. So if this is 108, then I can calculate this. So this angle here is 180 minus 108, which is 72 degrees. So now I know that this angle here is 72 degrees. Now think about all the other places I can do exactly that same math. There's a straight line here. And I know that this angle is 108, and therefore what must this angle be? Well, it must be 72 degrees by the same math. And keep going. There's a straight line here. And if this is 108, what must this be? 72 degrees. And you can see if you keep going around and around the star like that, that each of the angles on those triangles touching the polygon are the same measurement, and that measurement is 72. So all of these angles that I'm now marking are 72 degrees. So now let's look carefully at one triangle. So this is 72. This is 72. And this, we'll say it's A. Now, because it's a triangle, we know that the sum of the angles is 180, so I can say that 72 plus 72 plus A equals 180 degrees, and then I can solve for A. So 144 plus A is 180 degrees, and then solving for A, I get a value of 36 degrees. Now, exactly the same math will tell me that if A is 36, B is 36, C is 36, D is 36, and E is 36. They're all 36 degrees. And therefore, A plus B plus C plus D plus E is 5 times 36 degrees, which is 180 degrees. Now, obviously, I did a lot of erasing as I went through and showed you the results. Make sure that you're not on an EQAO erasing your math. Make sure that you're actually recording as you go and writing notes for the person so that they know what you're doing. You have my voice and you can rewind it, but on the EQAO, make sure you don't keep erasing what you do. So this is the end of video number 2. We still have a few more things to talk about in the geometry unit, plus lots more questions to take up together. So I will meet you in video number 3.